Welcome! Now we're going to talk about a different kind of expression. Last couple of lessons we were talking about numeric expressions, and this time we're going to talk about something called an algebraic expression. I'm going to write that right here next to my expressions title. Mostly so you can see the word itself, see how it's spelled. And we're going to talk a little bit about, first, what's the difference between a numeric and an algebraic expression. But first, if you notice my little list over here, this is going to have a lot of pieces. We have a lot to cover in this lesson, and I don't want it to go over like a half an hour. So I kind of made these real reminders for myself so that I don't forget something and then take up more time. So I'm going to try to make sure I cover all of these things in a relatively short amount of time. Okay, here we go. Ready? Got your pen ready? Got your journal ready? Okay. So a numeric expression, like we were looking at the last couple of lessons, dealt only with numbers and operations. Algebraic, we're going to introduce the variable. Now we've looked at variables a little bit. We played with them when we were solving proportions. Remember, we put two ratios together and we found a missing value. And this time we're going to look at them first in terms of where they fit in an expression like this if we don't know a value. And then we're going to start looking at more complex places and ways that variables can go together. Now, don't be scared. I'm going to show you a couple of expressions that you won't really mess around with until 8th grade math, probably Algebra 1. But I'm going to list them out for you just so that we can make sure that we know how to do these things, okay? So don't think that I'm going to ask you to like solve a complex equation or simplify horrendous expressions, but I do want to introduce you to the way a couple of things look so that we can recognize the pieces and parts of an expression. All right? An algebraic expression, like I said, involves variables. That means it involves something we don't know yet. I want to the first thing I want to do right now is build an expression with you based on a real life scenario. Okay? Let's say that my friend's birthday party is coming up and I want to get him some cupcakes, and I want to make sure that everybody that goes to this party gets a cupcake. The only thing I don't know right now is who he's invited. Okay? So I called the cupcake shop not too long ago and I got a quote. The cupcakes are $6 each because they're big fancy cupcakes. And if I go there in the next week, I get $10 off. It's a special they're having, all right? So $6 per cupcake, $10 off. I don't know how many cupcakes I need. So first thing I'm gonna do is I'm going to assign a variable, okay? What do I need a variable for? To represent the thing I don't know yet. I don't know how many cupcakes I need. So I'm gonna use C for cupcakes. So here's my variable. And that means the number of cupcakes I need to buy. There's my little note right there, just so I can remind myself what C stands for. That's an unknown, okay? But what I do know is that each cupcake is $6. So if I'm paying $6 for each, oh, there's that word each again, that kind of makes me think that I'm going to be multiplying, right? Aren't I going to multiply every cupcake by $6? So the number of cupcakes I have to order times $6. So right away, I know that I'm going to multiply 6 times C. Now here's the cool thing about variables. Since this is not a number, and I can't stick two numbers together because then it just looks like a bigger number. But when I have a variable, I don't really need this, because automatically a number stuck to a variable means multiplication, okay? There's multiplication happening here. I'm gonna make it a little clearer for us by moving the C a little closer, okay? So far, 6 times C means $6 times the number of cupcakes I need, all right? But I also mentioned, do you remember, that I get a $10 discount if I go within the next week. So whatever I would have paid for all these cupcakes, I can mathematically show that I'm also going to save $10. Okay? So for my trip to the cupcake shop, I'm going to pay $6 per cupcake and then subtract $10 from the total. And again, the only thing I don't know yet is how many cupcakes I need. What I just wrote here is an algebraic expression, okay? Now, before we go any further, what I want to do is I want to label the parts of this expression. It's very important to be able to look at an expression and know what the parts are, okay? So let's start over here. We know what this is. It's a variable, okay? It doesn't hurt to go ahead and say that again, right? Variable. Or, if I want to write it in parentheses, just so I don't forget what a variable is, this is the unknown. I don't know that yet. How about 6? 6 is being multiplied by the variable. Variables can be multiplied or divided by numbers like this. And if you have a multiplication or division happening to the variable, whatever's being multiplied or divided from that variable is what we call a coefficient. C-O-E-F-F-I-C-I-E-N-T. Coefficient. Multiplied or divided by the variable. In other words, stuck to it somehow, okay? You may see a coefficient stuck to a variable. You may see a variable sitting on top of a coefficient. This means C divided by 6, okay? You may see a fraction multiplied by the variable. Coefficient, 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 okay? You okay with that so far? We'll get to some more practice with this kind of idea a little bit later. Finally, what about that 10 off to the side? What about the minus 10? We call this guy, who's all by himself, he's separated from the variable by a subtraction or an addition sign, the constant. That's because no matter what happens over here, it's not going to change this, okay? The number of cupcakes will change this number, but it's not going to change my discount. My discount is always going to be $10, so it's constant, okay? If you want to make a note that the constant doesn't touch the variable, go ahead and do that. It's very important to remember that the variable and all of its friends are separated from the constant by a plus or a minus sign, okay? So these are the basic parts of an expression. One more thing. 6C and 10, separated by a plus or minus sign, are both called terms, okay? So here's a term, and here's a term. And usually that minus sign goes to that 10, but we'll get to that later. These are called terms. Terms are always separated by a plus or a minus sign, okay? Multiplication and division, that's a coefficient. Add, subtract, the constant is the number that we're adding or subtracting. That's all by itself, doesn't have a variable at all, but both of these are called terms. So this algebraic expression has two terms. 1, 2, separated by a minus sign. Okay? The anatomy of an expression. So far, so good? Let's try a couple of exercises. We just built that simple expression. Now let's try something a little more robust. Let's say we have 6x plus 2y minus 5. Algebraic expression? Sure it is. It can't be numeric, right? Because it has variables. Numeric expressions only have numbers and operations. This one has numbers variables and operations. So it's definitely algebraic. Now it might look kind of weird. You're like, what do I do with this thing? And we'll learn that a little bit later. But for now, I just want to ask you a couple of questions about it, okay? The first question I have for you, take a minute to look at it. How many terms does this expression have? Remember that a term is separated by a plus or a minus sign. In this case, I have a plus sign here and a minus sign here. So how many terms? 1, 2, 3. There are 3 terms. Not too bad, right? Next question. List the coefficients. How many coefficients are there in this expression? And what are they? Can you do that one? Try that. Remember that a coefficient is stuck to a variable, right? It's being multiplied or divided by a variable, or the variable is being divided by the coefficient. So how many coefficients do you see? Well, I have 2 variables. They both have coefficients, right? X has 6, y has 2. 2 coefficients. And if I were to ask you to list those coefficients, you would say here's 6 and here's 2. Good. There's 2. Okay, now what are the variables? Easy, right? There are 2 of them. 2 different ones. There's x and here's y. How about a constant? Does this expression have any constants? Numbers that are not attached to, not being multiplied, not divided by or being dividing a coefficient or a variable, they're all by themselves and they're separated by a plus or a minus sign. Do you see one of those? 5 is all by itself, right? Not attached to anything, separated from everything else by a subtraction sign. So we have one constant, and it's 5. Okay? Feeling pretty good about that? Okay. I'm going to throw something new in there now. Let's make a new expression. This time, I'm going to give one of my variables a power. 3x squared, or 3 times x to the second power. That means whatever x is, I'm going to have to multiply it by itself. Okay, I'm going to have to raise it to the second power. So there's one term, here's another, and here's another. Okay? 3x squared plus 2x minus 7. How many terms? 1, 2, 3. How many variables? That's like kind of a tricky one. How many different variables are there? Just because x is squared here doesn't make it different from this x. Okay, they're both x. Now we'll talk a little bit more about how these two are different right in a minute, but for now, these are both x. So this expression only has one variable, and that's x. Okay? Good, okay. Constant, is there a constant in here? Yeah, 7's all by itself. So separated from everything by a subtraction sign and doesn't have a variable. So there's our constant. Good. Now, I'm going to introduce you to a new word, and that's called degree. Each one of these terms has a degree, okay? And that degree is found by the exponent of the variable. Remember, this variable has an exponent of 2, right? This exponent, you can see it, but you can't see its exponent. Does it have an exponent? Remember that this one says that x is going to be represented twice. So if I were to write this in expanded form, this term alone would say 3 times x times x, okay? I just put those two x's together and said, there's 2 of them. But this one, there's only 1. So if I expanded this one, it would say 2 times x. You can't see it, but anytime you can actually see a variable and it doesn't have an exponent, you can assume that it has a power of 1, okay? What about this one? This one doesn't have a variable. I'll get into it a little bit. I'll get into it a little bit more later. But a constant has a degree of 0. Okay. So keep that in mind for a second. This one has a degree of 2. This term has a degree of 1. This constant, there's not a variable there, has a degree of 0. Okay. So this one has a degree of 2. I'm going to keep that in mind. I'm going to write it down. This one has a degree of 1, and this one has a degree of 0. So I have the degrees of all of my terms, okay? What's the degree of the whole expression? Well, this term has 2, this term has 1, this term has 0. The degree of the entire expression is just adding them all up. It's the sum of all those degrees. So basically I have this term plus this term plus this term. So the degree of this expression is 3. This is not quite as important as knowing the degree of each term, all right? This is going to come in handy, very handy, in Algebra 1, okay? When we actually want to list things in order of highest to least degree, all right? So if you're ever asked, hey, take this expression and list its terms in order from least to greatest or from greatest to least degree, you know you're looking at these numbers. Okay? That's an introduction. I'm not going to go much deeper into this because 6th grade, you don't need it yet. 7th grade, we will kind of pick up on listing them in order. And then in 8th grade, it'll come in a little more handy to just to have been introduced to this. Okay? As long as you know where to find the degree, you're in the right spot. But the next thing I want to talk about is what we call like terms. That's number 6 on my list. Okay? I'm going to tell you right now, this expression has no like terms. It does have the same variable here, but the terms are not like. To be a like term, this variable needs to look with its exponent exactly the same as this. These both have different exponents. These both have different degrees, so they are not the same. What if I wrote this? What if I said 3x plus 2x squared minus 7x? The only thing I did really is add an x to this term and added an x to this term. Do you think you see any like terms in this bottom expression? Those two, right? See how their exponent or their variables look exactly the same? They're both the same degree. They're both the same variable. The only thing different about them is their coefficients. But that doesn't matter. As long as the variables are exactly the same, you can call these two like terms. Because they're alike. They're like each other. They're the same. Okay? This one doesn't get to join that club though, because it only has that degree of 1. It doesn't have a degree of 2, so these two are, this one is not like terms with these two. These two are like terms. This guy's still by itself. Okay with like terms? Variables are the same, and the degrees are the same. Okay? Let's practice a little bit. I'm gonna give you some I'm gonna give you one really crazy looking expression, and this one's gonna come for your exercises, so pay attention because I'm about to give you an answer, okay? I am going to have 14x squared plus 3xy, which means 3 times x times y, okay? That's an interesting term. Minus 9x squared and minus y, all by itself. First thing I want to ask, how many terms are there? There's a plus sign, here's a minus sign, here's a minus sign, so there are 1, 2, 3, 4 terms, okay? 4 of them. Can you list the coefficients? This one's gonna, the reason I picked this expression is because it's gonna be a little tricky. How many are there? Here's one. Remember, it's anything that's stuck to or being multiplied or divided around next to a variable. Here's one, 14. Here's one, 3. Here's one, -9. And what's going on over here? Anytime you see a variable that doesn't have a coefficient, here's something to remember. There's automatically a 1 here. And you can totally write that, okay? Because it is there, it just doesn't always show up. So there's a 1 stuck to that y, and in this case, since it's a minus sign, this is a -1. So here's a coefficient, here's a coefficient, keep the sign to the left, here's a coefficient, and here's a coefficient. I'm gonna list them, 14, 3, -9, -1. So there are 4 coefficients for those 4 terms. Will there always be 4 coefficients if there are 4 terms? Not necessarily, but in this case, every single term has a variable, so there is a coefficient for every term. Okay, how about this? What are the variables? How many different variables are here? Well, here's an x, here's an xy, here's an x, and here's a y. Now just because this one is squared, and this one is stuck to a y, and this one is squared, so these two look alike, right? And this one is just y by itself, that doesn't mean that I have 3 different variables. I only have 2. I only have x and y, okay? Just because they're arranged differently doesn't mean they count as a whole different kind of variable. If it's an x and a y and that's all we see, then that's the only variables we're dealing with, okay? And then one last question, and this is another learning opportunity. I want to ask you what the degrees are of each term. Let's start with the easy one. What's the degree of this term? 2, right? It's the only variable and it's got a degree of 2. This one is the same way. Same degree, same variable. What about this y over here? What's its degree? Well, if you can see the variable, and it's all by itself and doesn't have an exponent, what can we automatically assume? That it's got a 1 there, right? So the degree of this term is 1. Excuse me. What about this one? Neither one of those variables has an exponent. So what can we assume about both of those? They each have their own degree. X has a degree of 1, because it's there, and y has a degree of 1, because it's there. So what's the degree of this term, the whole term? Well, it's just 1 plus 1. It's both of those together. So the degree of 3xy is 1 plus 1, 2. Degree of 2, degree of 2, degree of 2, degree of 1. Good. Excuse me. Allergies are bad right now. Okay. Last thing. Do you see any like terms? Look at it. Remember we said this one has the exact same variable as this one? Is xy the same as any of the other terms? It's the only one that looks like that. So this one doesn't have a like term. How about y? Negative 1y. Again, it's the only term in this expression that has a y all by itself. So this one doesn't get a partner. These two, though, are exactly the same. They have different coefficients, but their variables are exactly the same. They're both x's and they're both degree of 2. So our like terms are 14x squared and negative 9x squared. Okay? Don't let the funky looking stuff get confusing to you. What I really want you to do when you see an algebraic expression is take a breath, slow down, look at what the actual situation is asking you to do, okay? And the exercises that I've given you that you're gonna do underneath this video, I'm not gonna have you do everything at once. I'm actually gonna break this down and give you an expression and say, tell me what the terms are. How many terms are there? I'm gonna give you in the next section an expression, and I'm just gonna say, what are the like terms? List the like terms, okay? List the degrees for each term, all right? So don't get nervous, don't feel too overwhelmed, just take it one step at a time, all right? This stuff is very important though. So I want you to make sure that you're feeling pretty comfortable with this stuff on the exercises that I've given you. And we're gonna go over those together after you've had a chance to work on them. Because when we get into the next few lessons, we're going to be combining like terms, which means you need to be able to make sure you can tell what like terms look like. And we're also going to be filling in the blanks. In other words, I'm gonna give you a value for what x means, and we're going to then use order of operations like in the last lesson to find out the value of algebraic expressions. Let's not get ahead of ourselves though. For now, take some time to practice my exercises, and I'll meet you on the next lesson and see how you did, okay?